We're going to solve this integral using a special type of substitution. Whenever you see an integral of this form, we can use the substitution x equals to 2 cos u. And you will see why this is a good idea soon. So let's find the derivative of x equals to 2 cos u. So dx du equals to minus 2 sine u. And let's rearrange. We're going to get dx equals to minus 2 sine u times du. Always remember to convert the bounds of the integral when you're using substitution. So in this case, the upper bound, x equals to 2, we want to find u, so 2 equals to 2 cos u. So we have 1 equals to cos u, and u equals to 0. And the lower bound, we have x equals to minus 2, so minus 2 equals to 2 cos u. We cancel these two, we have minus 1 equals to cos u, so u equals to pi. So these are our two new bounds. Substituting 2 cos u for x, we get the integral of square root 4 minus 2 cos u all squared times dx. And remember, we've calculated our new bounds, so now it's between pi and 0. This becomes the integral between pi and 0 of square root 4 minus 4 cos squared u times dx. Now we can factorize out 4, so we can get square root of 4, 1 minus cos squared u times dx. And simplifying even more, we get 2 square root 1 minus cos squared u dx. Notice the expression we have inside the square root can be further simplified using the trig identity. Sine squared u plus cos squared u equals 1. And if we rearrange, we get sine squared u equals to 1 minus cos squared u, which is exactly what we have inside the square root. So this becomes the integral between pi and 0 of 2 times sine squared u dx. Here we can use the fact that the square root of a squared number is the absolute value of that number to simplify this even further to get the absolute value of pi between pi and 0 of 2 times the absolute value of sine u times dx. And now we can integrate dx by minus 2 sine u times du, which we found here on top, to get the integral between pi and 0 of 2 absolute value sine u times minus 2 sine u du. We can take out the 2's, so we get minus 4, the integral pi and 0 of absolute value of sine u times sine u du. And this becomes minus 4 pi 0 sine squared u du. Now we can make use of the double angle formula for cos 2u. So cos 2u equals to cos squared u minus sine squared u. Now we can use the identity we used before again. So this one to get rid of cos squared u. So we get cos 2u equals to 1 minus sine squared u minus sine squared u. Simplifying this, we get cos 2u equals to 1 sine squared u. And since we want to find an expression for sine squared u, we rearrange. So we get 2 sine squared u equals to 1 minus cos 2u. And sine squared u equals to 1 over 2 minus 1 over 2 cos 2u. Now going back to our integral, we get minus 4 times the integral between pi and 0. And instead of sine squared u, we have this new expression for it. So that will be 1 over 2 minus 1 over 2 cos 2u du. And now simplifying this, we get negative the integral between pi and 0 of 2 minus 2 cos 2u du. Now doing the actual integration, we get 2u, and this will be minus sine 2u. And that will be between pi and 0. Now we just have to simplify. So this will be minus. So it will be 2 times 0 minus sine 2 times 0 minus, it will be 2 times pi minus sine 2 pi. Simplifying again, we get minus, and this will be 0 minus sine 0 minus 2 pi plus sine 2 pi. And now we simplify again, so we get minus, and then 0, we take it out. And we know that sine of 0 is 0, so we also ignore that. We have minus 2 pi, and then sine of 2 pi is also 0, so we just do plus 0. And now for the final step, we just multiply out the negative sign, so we have 2 pi. And this is our answer. So to summarize, the integral between minus 2 and 2 of square root 4 minus x squared dx equals to 2 pi.